All right, let's get right into this. We are looking at what is basically a cosmic crime scene, 730 million light years away. The victim? A giant star. And the cause of death? Well, it was an explosion so bizarre, it took a brand new kind of artificial intelligence just to spot it in time. This is the story of how astronomers, with a huge assist from AI, solved the mystery of a truly impossible stellar explosion.
And that brings us to the central mystery of this whole cosmic detective story. You see, when a massive star dies, it's supposed to go supernova. That's a single, final, brilliant explosion. But this star? This one seemed to die, and then, months later, it kind of died again? I mean, how is that even possible?
So our story really kicks off with the very strange case of a supernova called SN 2023 ZKD. Now, it was first officially flagged as an explosion back in July of 2023. But the real mystery, well, it had started years before that, and it continued long after.
Okay, so just so we're all on the same page, this is what a supernova is supposed to be. A massive star runs out of fuel, its core collapses, and boom, it goes out in one final spectacular blaze of glory. It's a one-and-done event. Simple, powerful, and, final. But SN 2023 ZKD, yeah, it didn't play by the rules. And this is where the puzzle for astronomers got really interesting. When they looked back at older data, they saw the star system had been slowly getting brighter for over 4 years before the main event. Then, in July 2023, the big supernova explosion happened, right on schedule. But then, months later, just when it should have been fading away, it got bright again. This whole timeline, it just didn't add up.
So to solve a puzzle this strange, happening in real time, millions of light years away, you're going to need a new kind of detective. One that can work at impossible speeds and sift through an unimaginable amount of data. And that's where the AI comes in.
Just look at this number. This really shows you the scale of the challenge. Every 3 nights, this project, the Young Supernova Experiment, scans 4% of the entire visible sky. I mean, that's an area holding thousands of potential cosmic explosions. It's a complete flood of data, way too much for any human team to analyze in real time. The weirdest, most interesting events could just slip right through the cracks. So what you're seeing here is a brand new kind of partnership in astronomy. Humans were fantastic at looking at something strange and going, wait a second, that's not right. But the AI algorithm, it can do that initial massive scan. It flags the weird stuff instantly, which lets astronomers point their big telescopes at the event right away and capture that crucial, fleeting data before it disappears forever. And thanks to that super early alert from the AI, astronomers were able to analyze the light from this explosion in incredible detail. And that light, well, it told a story.
The key was figuring out how to read these signals. That long, slow brightening, that suggested the star was shedding material for years. The first big peak of light, that was the supernova's blast wave hitting all that thin, low-density gas. But the second, delayed peak, that was the same blast wave finally crashing into a much thicker, disc-shaped cloud of stuff further out. This structure, a disk, that was the smoking gun.
So what on Earth could cause something like that? A star doesn't just shed its outer layers into a neat disk on its own. That weird structure and the years of instability, it all pointed to one thing. Something else was nearby, pulling on it. This star was being tormented by the intense gravity of a close, unseen partner.
So who was this mysterious companion? What could it be? Well, all the evidence pointed to one of the most extreme objects in the entire universe. This wasn't just any old star system, this was a deadly dance with a black hole.
So here's the leading theory of what actually happened. First, you've got this massive star locked in orbit with a black hole. Second, the black hole's insane gravity starts siphoning gas and dust off the star, and that creates the disk we saw the evidence for. Third, as they spiral closer and closer, the gravitational stress gets so intense, it actually triggers the star's core to collapse and explode. And finally, the debris from that explosion slams into the disk the black hole had just created, and that's what causes that bizarre second flash of light. The black hole didn't just watch the star die, it was the trigger, it caused it.
And this wasn't an easy conclusion for them to reach. As one of the astronomers, Ryan Foley, said, the whole idea sounded like science fiction even to them. They had to be incredibly methodical, checking every single piece of data to make sure all the observations actually lined up with this wild explanation. And you know what? They did.
So, an AI helps find a star that was killed by a black hole. It's an absolutely incredible story, but what does it all mean? Why does this discovery really matter, beyond just being a wild piece of cosmic trivia?
For the world of astronomy, this is huge. For one, it's the best proof we have that this bizarre, violent way for a star to die is actually possible. It basically opens up a whole new category of cosmic explosions for us to look for. And maybe, most importantly, it proves that this team-up between AI and humans is the future for discovering these fleeting, time-sensitive events.
And what's so powerful here is that this technology isn't just for looking at the stars. The same basic idea, an AI that sifts through massive amounts of data in real time to find that one critical anomaly, has huge applications right here on Earth. I mean, imagine using this to screen for diseases earlier, or to detect financial fraud as it happens, or even to help identify people who need early mental health support.
Which really leaves us with a final thought to chew on. We've built an AI that can act like a watchdog across the entire cosmos, spotting a unique stellar death before it fades from view. If it can do that from 730 million light-years away, what other hidden patterns, what other critical anomalies is it about to uncover for us right here at home?